We have finished most of our module content for fluid mechanics. Now we are moving to the last couple of topics. They are dimensional analysis and similarity. Solving fluid mechanical problems are not easy due to the complexity. Therefore, basically it has an experimental investigation phase. Dimensional analysis allow the identification of groups of variables whose interrelationships may be determined experimentally. Let us refer the figure. This experimental setup gives a model test carried out to look at the stability of a revetment in the coastal environment. Please observe the colored rocks or blocks in model and also the set of cameras to detect the dislodgement of them. The result of this model test is forecasted to the real world situation, which could be a massive structure. Model tests are extremely important to the feasibility analysis of big projects to look at the stability. This is greatly cost effective. Now, let us look at the units and dimensions. We are only using international standard units in our module. For dimensions, we define three independent basic properties. They are mass by block M, length by block L, and time by block T. We can define dimensions for most of the units. You can see the definitions or the obtaining of dimensions for various units. Dimensions give qualitative analysis, not the quantitative. Therefore, dimensions usually written inside the brackets. Let us look at the properties of dimensions in equations. If we have an equation, the equation tells both sides of the equation are numerically and dimensionally identical. Please understand these examples. When x plus y is equal to z, x, y, z should have same dimensions. It's just like 1 meter plus 2 meters are 3 meters. There are some dimensionless measurements and they do not have any units. Strain is such measurement. And there are some other measurements with units but without dimensions. Angle or angular measurements are such examples. These tables give you the basic units. Derived units from basic units. Dimensions of the regular units. Please go through these tables and get familiarized of units and dimensions. Now we come to one of the most important tables for remember in our life. That is unit conversion table. We usually know kilo, mega from the upper side and milli and micro from the lower side. However, we might need some other conversions depending on the situation or depending on the application. With that, let us move to the dimensional analysis. We know Indicial method, which we have used in our high school to derive the equations. Try these two examples. A force is a function of mass m, acceleration a, velocity v. Then try to obtain the equation for a force is a function of mass m, acceleration a, velocity v, and distance s. You will find out that the second example is unsolvable from Indicial method. Therefore, if there are more than 4 variables, we can't use Indicial method to solve the equation. Therefore, we move to an alternative method, that is Buckingham Pi method. Basically, we list all variables and write the dimensions. Let us say the number of variables are nv. We have three basic dimensions m, l, t and call them nd. Phi theorem method says we can obtain nv minus nd number of pi numbers, and all these pi numbers are dimensionless. Therefore, our equation is pi 1 is a function of pi 2, pi 3, which goes to pi n. Now this n can be found out from nv minus nd. Pi 1 usually incorporated the dependent variable and use other independent variables to make pi 1 dimensionless. Then use other pi numbers or derive other pi numbers using the repetitive variables using the Indicial method. Hint: use the non-dimensionless groups like Reynolds number, Freud's number and so on. Remember, we go only with 4 variables since we can only solve 4 variables to bring these pi numbers. And also you need experience to get these pi numbers in the real world cases. Try these example and obtain the expression for force and for the variables of velocity, length, density, dynamic viscosity and gravity.